Uh, Hello all, this is Anusha Nandam. Today I'm going to present my project report uh, based on the CKY parsing. I have to do on my project based on the tourist site application. In this particular project, we do define the couple of statements like discover the beaches in the country, experience the Taj Mahal in India, you recommend a monument, Anusha visit the destination place and enjoy the world. Anusha explore the Great Wall of China and you visit the Eiffel Tower. You plan for the trip and recommend the landmarks in the city. We are going to define in this particular project. There were a couple of statements which we need to define, like valid and invalid statements. Coming to the introduction of my project, my title of the project is World Tourist Site Application. So, based on the statements, we are going to define a grammar, which is completely based on the Chomsky normal form, and we are transferring the Chomsky normal form to CKY parsing method, and make sure that all statements which we are going to provide, whether it is a valid or invalid. This is about the basic introduction about my project, and coming to the context free grammar, CFG. CFG is basically a normal grammar. This is a lexical grammar based on based on my tourist site applications. After I defined a couple of valid or invalid statements, I have to convert NCFG to CFG. So if you could see the CFG grammar, so on the left hand side, all are non-terminals, and on the right hand side, either it could be a terminal or non-terminal. So in which S produces NP and VP. Both are going to be two non-terminals, and also we have A and D, which are going to be the terminals. And also there are few rules to convert CFG to CNF. So in CNF, on the left hand side, it's as usual, and on the right hand side, um, it could be a terminal. Either it can be a one terminal, a single terminal, or non-terminal. For example, right here, if you could see the S. It is going to the S produces NP and VP, are both are non-terminal. So basically, we convert the CFG to CNF. There are a couple of rules like eliminating the unary production, and also making sure that we have two non-terminals on the right hand side. So and these are going to be my input statements, so under which it is going to divide it into two categories: accepted statements and not accepted statements. Coming to the logical part, I have used Jupyter to write my Python code. So if you could see on my dashboard, to look on the project. So this is basically a logical portion of the CKY parsing. So here we have defined the grammar. It looks in a form of string. After that, we are passing the grammar to the CKY parsing method. So after passing the CKY parser method, we are storing a variable called a parser. We are passing this parser. If you could see on the second cell, there is a CKY parser, and after passing the CKY parser method, we are going to store a variable called a parser. We are passing this parser we are going to pass this parser. So we are after that we are taking a sentence in the form of a text format. For example, if I'm going to run this particular cell, so it is asking to provide an input like please enter a sentence to parse. So here I'm going to provide one sentence like visit India, and I'm going to run this code, and I could see the sentence is not passed successfully. So whatever we gonna give as a input variable, it gonna save it in a parse method as a sentences. So we are going to send these variables to the parse method. So this particular method we will pass a sentence as a parameter. So it is going to break our sentences into the words uh, by using the token side. So yeah, if you could see here this particular line, the list of words equal to NLTK word token size sentence. So here it is going to break our sentences into words using the token size keywords. After breaking the sentence, we are going to calculate the length of the word of a list of words to create an empty table. So based on the rules in the CKY parsing, so let's take an example. We are going to create a table like we are going to create a table like um, for this particular statement, like discover the beaches in the country. So here it is a uh, 6 column table. So this table we call it as a upper diagonal table. So here in the CKY parsing, we will fill the columns from left to right and bottom to top. So first I'm gonna fill the first cell, then 0 to 1, 0 to 2, 0 to 3, 0 to 4, and 0 to 5. After that, 0 to 6. So right here, there were various permutations and combinations of cells which I am going to split into. Uh, so here we're gonna check all the combinations of a noun verb. So noun VP, proper noun VP, and NP verb, nominal S, and nominal VP, preposition. So this is the example of the CKY parsing table. And likewise, we are going to check for all the cells for all the coordinates. So the most part is how we gonna know whether the statement is valid or invalid. So if you could see on the logical part, uh, on the last input sentence cell, so there is one statement which I have defined in my logic, like if the sentence if the result is going to pass yes, I mean the end of the sentence, uh, like country or top right of the corner corresponded to that word cell must contain non-terminal s. Otherwise, it is not going to be considered as a valid statement. And the basic operation, it gonna check for left hand side and right hand side productions. So if the last cell contain the result as s, then the sentence is a valid one. And if it is not accepted by the CKY parser, then it will throw a error message like the sentence is not passed successfully. So based on that, we can define our code, whether it is a uh, whatever the sentence which we are going to provide, whether it is a valid or invalid. Let's run this an example. So I'm going to run my code again. So under the Jupyter libraries here, I have created my project as Anusha CKW project. So yeah, so this is my piece of code. Now I'm going to run all my cells. It seems to be some problem with the server. Let me execute my code again. Seems to be some technical glitch in my system, I guess. Uh, Let me run it again. Yeah, this gets go. I'm going to run my code again. It seems to be there is some problem with my network. Let me rerun the code again.